Hello all. So in unit 1 we have seen what is NLP, how do we work with NLP, and then we have looked into few libraries, we have seen NLP tasks, and then we've also seen how do we do text pre-processing in the context of NLP, and then we have looked into the important concepts of NLP, which is word embeddings, right? Now we'll start with unit 2 wherein we start with sentence classification. Okay, so when I talk about sentence classification, okay, so far in unit 1 we have given machine ability to understand words, characters, and then the corresponding word embeddings. Now we progress ahead and understand how do we make machine understand a sentence and classify the given sentence. Okay, so we look into what sentence classification all about, and we'll also see recurrent neural networks, the main important neural network models which we use for processing natural language. Okay, so when I talk about sentence classification, okay, so here it is a task of NLP where the NLP model receives a sentence as input and assigns some label to output. So there are many different applications of sentence classification, like when I talk about sentiment analysis, okay, or movie reviews, okay, product reviews, the input here is a sentence, and then the output would be the classification of that particular sentence. When I talk about a movie review, the movie is good, bad, or average. When I talk about a product, okay, the product is good, bad, or average. Okay, so the input here is the sentence, and the output here and the output is the classification of that particular sentence. Along with this, email filtering is also one of the important applications of sentence classification task. Okay, so here the input is a email, whether it is spam or not spam, it decided by the classifier. Okay, so here we take the email as an input, classify that, and send that particular input either to inbox or spam. Okay, so how do we process this sentence? Okay, when I talk about sentence classification, how do we process this sentence is by using recurrent neural networks, okay, RNNs. So in deep learning and in machine learning, we have discussed about after basic machine learning models, we have discussed about two important neural networks, which are artificial neural networks, which is used for processing large text data, and then we've also seen convolutional neural networks, which we use for processing the image data. So along with ANNs and CNNs, we use the third type of neural network here, which is called as recurrent neural network when we deal with natural language processing. Okay, now recurrent neural networks are one of the most important concepts or the most important neural networks that we use in natural language processing. Okay, so the most important characteristic of RNNs are they have internal memory, which makes them powerful. Okay, so RNNs are the only neural network models which have internal model which has internal memory, which make them robust and powerful. Okay, when I talk about RNNs, they process the language data or text data in sequential order. So this is the most important characteristic of RNN. So recurrent neural networks have internal memory and they process the data, textual data, in sequential order. Okay, so by processing the data in sequential model, it allows them to be very precise in predicting what's coming next depending upon the previous words in the given sentence. Okay, now why do we actually need recurrent neural networks? Okay, so when we talk about the context of natural language processing, the other neural networks will not. When I talk about other neural networks, feed forward neural networks may not be able to handle sequential data, and they consider only the current input. I cannot predict the next word in the sentence based only on my current input, because based on past input also, past input and current input, I may predict the words in the natural language. Okay, so the other neural networks may not be able to handle sequential data. They consider only the current input and there is no internal memory, hence they cannot memorize the previous input. So in order to solve the problem, these three problems in the previous neural networks, we go for RNN. So RNN can handle sequential data, accepting the current input data and previously read inputs, and as RNNs have internal memory, they can memorize the previous inputs. Okay, this is why we need RNNs. Okay, now the next topic is how do RNNs work. Okay, so when we talk about this, I as already told you, RNN works on sequential data. RNN process sequential data. When I talk about sequential data, it is basically the data which is ordered. Okay, so if I take a sentence, I am Asha, this is an ordered data. Here the sequence is I am Asha. This is a meaningful sentence. But if I change the sequence saying Asha am I, Asha I am, or whatever it is, it does not give a meaningful sentence. So if when I talk about natural language processing, the context, the structure of the sentence is important, for which I have to process the data in the sequential order, and RNN does that job for us. Okay. Now, the most popular type of sequential data is perhaps time series data, which is just a series of data that, a series of data points that are actually listed in the time order. Okay. Now, let us see in what way RNN architecture is different from the previous feed forward neural networks or basic neural networks. Okay. So, when you look into this picture, the two images here depicts the difference in how the information is flowing in between the recurrent neural network and the feed forward neural network. Okay. So, when we look into this feed forward neural network, we have input layers, we have hidden layers, and we have output layers. The input from the hidden layers would be the data from the input layer would be given to the hidden layers through weights and biases, and then through hidden layers using activation functions we get the output, right. So, in contrast to this, okay, when you observe this neural network here, we have this feedback loop for each and every neuron in the hidden layer. Okay. So, this is the difference between feed forward neural network and recurrent neural network. Okay. So, basically a recurrent neural network will have the ability to remember the data, okay, because of its internal memory. That feedback loop that we are giving serves as an internal memory which will remember the previous data. Okay. Now, simply put, okay, so simply closing this particular topic, I say recurrent neural networks add the immediate past to the present. I say recurrent neural networks add immediate past to the present. When I talk about processing this sentence, I am Asha, first I will be taken, next am. So, when I take the next word am, I should add this word am, which is the current word, to the past word which is I. So, the sentence here would be I am, and the third word here is Asha. So, I have to add the previous words I am to this Asha to complete the sentence. So, first I take I, and then I read am with I am, and then I read Asha with I am Asha. So, I am able to read the previous words because I have a feedback loop for each and every neuron. Okay. So, therefore, we say RNN has basically two inputs, the present and the past, the recent past. Okay. So, this is how the sequence of data or sequential data is processed using RNNs. Okay. Now, there is another concept in RNN, or the main the concept in RNN is this recurrent neuron and the concept of unfolding. Okay. Now, let us see what is this recurrent neuron and what is this RNN unfolding. Okay. So, recurrent unit is basically the fundamental processing unit in RNNs. Okay. So, this is the diagram for recurrent unit. Here I have my input, here I have my output. In the hidden layers I have this feedback. So, from the input layer to the hidden layers I take a feedback loop and process that particular input to the output. Okay. So, this is called as recurrent unit. Okay, or we call it as recurrent neuron. And what does this unit do? When we talk about this unit will have the ability to maintain the hidden state. Here the H represents hidden state, allowing the network to capture sequential dependencies of previous inputs. Okay. So, here the hidden state will have the ability to remember the previous inputs while processing the current text data. Okay. So, this is called as recurrent neuron. Okay. Now, when we talk about unfolding or unrolling, okay, so this is nothing but we write out the network for the complete sequence. When I told you I have three words, I am Asha. So, three words would be processed in three different neuron units. Okay, so if the sequence we care about has 3 words, the network would be unrolled into 3-layer neural network. Okay, so this is a simple one particular neuron. When I talk about 3 words, we go for 3-layer neuron network, 3-layer neural network, where one layer is used for one word. So this would be I am ASHA. So the current word if I am processing is am, I would be the previous word which would be added together, and I am would be given here for the V, and ASHA would be added to that particular sentence. Okay, so this concept is called as unrolling. Okay. Now, what are the different types of neural networks? So there are 4 basic important types of neural networks. The first one is called as one-to-one, second one is called as one-to-many, many-to-one, and many-to-many. So depending on the applications that we choose on sentence classification, we either choose any of these architectures. For example, when I talk about the first one, which is one-to-one, okay, so this is the simple architecture depiction of every model. When I talk about one-to-one, one input, one output. When I talk about one-to-many, one input, multiple outputs. When I talk about many-to-one, multiple inputs, one output. Many-to-many is multiple inputs and multiple outputs. Okay, so when I take an example of image classification, I have one image and I have one class for that particular image. So here I go for one-to-one architecture. This image, the image belongs to this class. Cat, if I give an image of cat, so cat is one input, image is one input, cat is the output of that particular image. Okay, so one-to-one are plain neural networks. Okay, they have one input and one output. When I talk about one-to-many, okay, image captioning, input here is image, output here is the caption where I have multiple words. So one input with multiple words as output in image captioning. Okay, now the third one here is one-to-many. Okay, when I talk about one-to-many, sorry, third one here is many-to-one. Okay, so sentiment analysis. Okay, so I give multiple sentences in the given input and the output would be good, bad, neutral. Okay, positive, negative, or neutral. Multiple sentences or multiple words, output is only good, bad, or neutral. Okay, and last one, it is many-to-many. When I talk about many-to-many, language translation. Okay, here also it is sentence classification task. My input is a language, sentence with one language, output is the sentence with another language. So multiple words in the input, multiple words in the output. So depending upon the task that we choose, we either choose any of these 4 architectures, whether one-to-one, one-to-many, many-to-one, or many-to-many. Okay. Now advantages of RNN. When I talk about advantages, RNNs are the only neural network model which has internal memory. RNNs are the only neural networks which can process sequential data. Okay, and then RNNs can also be used with convolutional neural networks which will extend the active pixel modes that we will see in the next coming units. Okay, so when I talk about disadvantages, same thing, like as we have seen in the neural networks where we have forward propagation, backward propagation, optimization, updating weights, wherein we encounter gradient descent problem. Okay, vanishing gradients, exploding gradients. So RNN also deals with coming back to the previous input. So we have vanishing and exploding gradient problem here, and RNN, training an RNN is a complicated task, obviously, because processing natural language is not that easy task, and it could not process very long sequences. The basic or simple RNN architecture cannot process longer or lengthier sequences, for which we go for other alternatives called LSTM and GRUs, which are our next topic. Okay. Now, what are the other variants of RNN? As discussed, we have bidirectional neural networks. Because our RNNs are not able to process longer sequences, we have bidirectional neural networks. We also have LSTMs, we also have GRUs, which we will discuss in the coming sessions. Thank you so much.